right, these notes are for chapter 2.2. This is practice problems number 2, so this is part 2 for that. So in the first part, we graphed based on two types of equation, the vertex equation, which is very, very useful, and the standard form of the equation, which is just okay. Now this one we're going to have the intercept form. This is the intercept form here. Here's our A out front, just like before. Now these two, when they're factored like this, that tells us what our x-intercepts are. If you set each one of these equal to 0, like if x plus 4 equals 0, you get x equals negative 4. If x minus 2 equals 0, you get x equals 2. So our two intercepts are at 2 and negative 4. So we can put those on our graph. Now, the axis of symmetry, just to put those points down, write them down here. So we have negative 4, 0, and 2, 0. Now the axis of symmetry has to run right down the middle of those because the parabolas are symmetric. So to find out where that's at, we want to average those two x-intercepts. So we take a negative 4 plus 2 divided by 2. Well, that's a negative 2 divided by 2, which is negative 1. So our axis of symmetry here is at x equals negative 1. So we know our vertex is going to lie on this vertical line right here. Now to find the y-coordinate, we're going to take that negative 1 and plug it back into our equation. So we have y equals a negative 1/3 times negative 1 plus 4 times negative 1 minus 2. So that's positive 3. That's negative 3, and we have a negative 1/3. So negative 3 times 3 is a negative 9, times a negative 1/3 is a positive 3. So it tells us our vertex is at the point negative 1, 3. So negative 1, 3. That's enough to graph our parabola. So we know the two x-intercepts, we know the vertex, and it works out right. It went up and down because our A was negative. Now increasing and decreasing, well, it's increasing here on the left. So that's from negative infinity over to negative 1. Remember, we always use the x-coordinates for these intervals. So negative infinity over to negative 1. And it's decreasing on the right side, so that starts at negative 1 to the right. So negative 1 to infinity. Like I mentioned in the last notes, when you do these intervals, they're always parentheses, never a bracket. Okay? Next one, another one that's in intercept form. So we come up here and say, okay, if we set x equals 0, we get 0. If we set x minus 2 equals 0, we get 2. So our two intercepts are at 0 and 2. So our intercepts are at 0, 0, and 2, 0. So our axis of symmetry has to be right in between there. So we average those, so 0 plus 2 divided by 2 is 1. So our axis of symmetry is x equals 1. So the middle of the parabola runs right through here. So our vertex is going to have an x value of 1. To find the y value, we substitute in. So y would be 2 times 1 times 1 minus 2. Well, that's a negative 1. So 2 times a negative 1 is negative 2. So our vertex, oops, I wrote an x in there, sorry. Our vertex is 1, negative 2. So 1, negative 2. So that's enough to graph our parabola. Again, it opens up. You see our A was positive, so it should open up, and it did. Now, so this is increasing here on the right side because it's got a positive slope over there. Well, that's from x equals 1 to infinity. It's decreasing over here on the left side, so that's from negative infinity to 1. Then, practical problems are on these ways that these quadratics come up. A lot of projectile motion is quadratic. So that comes up a lot when you deal with anything thrown or anything like that. Here it talked about a softball being hit. Now here you're given the formula. So this formula tells you that at whenever x, that's the horizontal distance, so however far it goes over, then f of x is the height of the ball at that time. So if you were tracking that ball, if you flew 100 feet, you would plug in 100, and that would tell you how high the ball is off of the ground at that point. So that's what's involved in this equation. Now the highest point, well, if you notice here, our A is negative, so we know this one opens down, so it will have a max. So it has a highest point, it's going to have a maximum point, and that's going to be the vertex. So we need to find the vertex. You're going to have to use a calculator at one point on this because of the decimals. But one, we can find out where that happens at. Remember we had that little formula that says x equals negative b over 2a. That gives us our axis of symmetry, or the x-coordinate of our vertex. We're going to do that here. So we have a negative here. Our b is 0.2127 over 2a. That's going to be 2 times a negative 0.0005. So we're going to work that out. That's going to give us the x-coordinate of our vertex. Well, if you put that in your calculator, I got 212.7 feet. So if we're thinking of the path of that ball, so you hit the ball here. If I hit the ball and here's its path after I hit it, when we've gone over 212.7 feet, that's when that ball's at its highest. So this is our maximum height right here. Now to find that height, we're going to plug that into our equation. Dark to see this, but we'll give it a shot. So if we plug that in here, we're going to take, our equation says a negative 0.0005 times 212.7 squared plus 0.2127 times 212.7 plus 3. Can't see that very well, but I have 25.62 feet. So that's when that ball is at its highest. When you've gone over 212.7 feet, it's 25 feet off the ground. That's the highest it gets. That's pretty low. That was a pretty good line drive hit there. Right. Another way to do this is you could put that in. I can't see this very well, but you could go to your y equals and plug that in. So here I've plugged in. You can't see it very well, but I've plugged in that equation. So I have a negative 0.0005 x squared plus 0.2127x plus 3. The only tricky part about that is graphing it. You're going to have to play with your window to graph it. Like if I go to window, let's see, x min, well, the smallest x I need is 0. How far is that ball going to travel? I don't know. I'm going to put 500 feet. For x max, I'm going to put 500. For y min, well, it's never going to get below 0 because it's going to be above the ground. Y max, well, we just said the max was 25 feet, so I put it at 30 so I had room. Now, if I graph that, if we want to find that vertex on top, you can go second calc. Notice this has a maximum. Well, number 4 says maximum. It's going to ask me left bound, so I want to move my cursor to, I want to move it to the left of the top of that parabola, anywhere to the left. So somewhere to the left and hit enter, then it'll say right bound. Now I'm going to move it so it's somewhere right of the top of that parabola and hit enter. And then for guess, I'm going to hit enter one more time. And it gives me the same answer. 212.6 something, about 212.7 feet and 25.62 feet. Okay. Now the next part of that one says, if the ball was hit to center field, which has an 8-foot fence located 410 feet from home plate, was this hit a home run? Well, what you can do here is we could put 410 into that equation. So we'd find f of 410. So again, we would plug that into the calculator. So negative 0.0005 x squared. For x, we're going to put 400 squared, 410 squared, excuse me, plus 0.2127 times 410 plus 3. So if you enter that in the calculator, I got 6.157. Another way to do that, if you have that graph, is I could hit trace. So on the top, if I hit trace and I punch in that 410 and hit enter, it'll tell me right then, it'll tell me what my height is. So there it says it's 6.157. So if you always have a graph, that's an easy way to find it, is put in the x value, which here is 410, and it'll tell you the y value. So if you can see that a little better on the calculator. So here's what I plugged in under y equals. That's the equation. Here's my window. So x went from 0 to 500 because I figured the ball wouldn't go past 500. Y min was 0. Y max I set at 30. I could have gone more, but I already knew my answer. Then we graph that. Again, if you want to find the vertex, you can do second calc, and then number 4 says maximum. Then it says left bound, so I go left. You can see my cursor. I need to go a long ways. So I use my left arrow to go left of the top of that parabola and hit enter. Then it'll say right bound, so now I move my cursor so I'm somewhere right of the top of that parabola and hit enter. Then it says guess. I'll hit enter one more time, and it tells me the top, 212.69998 for x, and y is 25.62. Then for that second question mentioned, if I hit the trace button up here in the top, I hit trace and punch in my x value, which is 410, and hit enter, it tells me it's 6.157. So that tells you that, and when that ball's gone 410 feet, it's 6.157 feet above the ground. This is a pretty strong softball player if they're hitting the ball. 410 feet is a pretty good shot for a softball player. Anyway, that is 2.2 part 2.